Hi there.
Hello.
Hello.
Hi. Anybody can hear me?
Yes, all right.
Yes.
We can hear you.
And just to say, the room can hear you as well. I presume Turles is coming in person, is he?
Hi.
Hey.
Yeah. Where is Terrace? So we miss our local chair. Okay. Anyway, I think that's time. Can you hear my screen, the chair slides?
Now I can see your slides.
Okay. So it's 9 o'clock. Although we miss our local chair, Terrace, we should start our our meeting. This is Anima Working Group meeting. This is held by the chair, Terence Eckert, and myself, Xinjiang. First of all, I need to notify everyone I changed my affiliation. I'm now the professor in Beijing University of Post and Telecommunication. So that's my new job. I just start this August, and I'm still here, serve as the anima chair, because I just start my new job. So I don't have funding and the support to travel to London this time, but it's in my plan to Japan next March. So, and this is the IETF note wheel. Everybody attend the meeting should read this and behave well as stated in this note wheel. This is our basic information. Chair, myself, and Terence, and we have our area and director Robert Wilton. We published our agenda, and the minutes is taken by myself and also Eugene. All the slides already uploaded, and we have this video stream. For this meeting, there's no physical blue sheets. It will take according to the video stream, and there's no jabber anymore. We encourage the early IPR. Hold on a second, I should start my video, I guess. Oh, there it is.
Yep.
You're already on site. Oh,
Yep,
okay, you can take over. That
Please
will be
continue if you
better,
want.
I guess.
Yep.
You can take over.
Yeah. So there is.
Do you
really
want to share your slides or?
No, this is fine. You can keep the slides, and I'll continue after.
Can you get closer to the mic? We can barely hear you.
Yeah. No, I just from the prior slide, please go into the Meet Echo tool, so that you're being counted as participants in the working group, especially when you're in the room, because otherwise next time there may not be enough seats, although we're fine right now, but that's how you're being counted by being in the Meet Echo. That's the new thing. And also the note taking, right? You see the note page that everybody can edit it. So please help us with taking the notes when we are in the discussion sections of the different presentations, so that we capture what's being done in the meeting this time. Next slide.
You are in the IPR disclosure page.
Yeah. Right. So the IPR early discuss the IPR disclosure. So we're a working group that is asking for IPR disclosures when a draft is being adopted by the working group, and not only when it is released to the ISG, which is kind of the old process, but I think now most working groups have changed to the early IPR disclosure process. Next slide. Okay, so when you're in implementing, using, reading ANIMA work, and you are discovering errors, you know, there is an error process to report errors to the RFC editor so that they're tracked and can be verified or rejected. And we have 4 published erratas so we have erratas for 4 of the RFCs we've published. So if you're implementing, also be sure that you read the errata, so that things that are wrong in the RFCs, that you're taking that into account when you're doing implementations against them. Next slide. So, and here is the set of the working group documents. So we have 9 active working documents. 1 is expired. We have 4 working group documents for which we have not received slots to speak about them in the working group meeting today. And for one of them, we received, for the ANIMA grasp distribution, we received notification by the authors that they are working on it and hope to have an update for the draft at IETF115. And for the others, we haven't received information about why they're unchanged from IETF114. So if any of the authors would like to stand up now and say something about it, so that as possible we can put it up in the notes. Let me just also take some time to get myself in the notes section. So that I can take notes here. Sorry. Okay, here we are. Okay, nobody from the authors here wanting to say something about this? Let me see. Sorry? I'm asking if there is any update on any of these 3 other drafts with respect to why they didn't seem to have received work since IETF 114, 113.
I mean, the reason why they didn't is not important, but what important is what their plans for next.
I thought I replied to your email about this. Brewski Cloud's been waiting for working group last call for more than 2 IETFs. That's why it's not changed. Grasp distribution, I can't speak to that work. Voucher delegation may or may not be irrelevant or uninteresting to anybody at this point. RC 8366 BIS is still interesting, but other work took priority. So that's why there's no result on that. But as soon as we get the the constrained stuff out of my queue, then I will come back to that for sure.
Okay. Note take.
Okay. Okay. So I'll put up in the TBD
Michael?
items to do.
Michael, I do have a question. When you say you may have the time slots for the RFC 8366 bits, do you mean before next IETF meeting?
Do I think we'll work on it before 115 is your question? Seems reasonable to me that it will make progress before then. I mean, I'm assuming that the constraint voucher, we're going to finish it this year, and one is, so I would say it's just, you can't focus on 12 things, you get nothing done, right? So that's the major part.
Okay, then I will take your words as you will do something before next IETF meeting as a notes. Thanks.
Right. Okay, and I've put down that Cheng and I need to look into the working group last call for Brewski Cloud and likely get that out quickly. Okay, so not going to talk about the drafts for which we have slots in this meeting. Next slide.
Just a short question. I raised my hand, but
Oh, okay, sorry.
I just speak up. One question to, yep, thank you. One question to Michael. Michael, you said voucher delegation will be irrelevant. Did I capture that right, or was it just regarding the state and technical content still will evolve?
You tell me. So we entered this with great enthusiasm a year and a half ago or something, and the use case came from a number of different places. One of them was OPCUA, and they've moved on. The time for that for them has passed. And the possibility to align them, their thing that they called a voucher, which really was not, to align it with what we're doing, that window's over. They don't have a lot of interest in that. They do need the assembly process, and they have an interesting process, a different process to build assemblies, which is very different than what we did. So their interest in that is gone. Now, Stefan, I know you have some other interest within Siemens for some of this stuff, and so I would say that we need to figure out what remains from that part, and it may or may not be relevant anymore, is what I'm trying to say, Stefan.
Okay. So
I think that I think that this is work that has value, but I just don't know that we actually have a customer for any of it, and I don't see a point in spending a lot of time doing a lot of things if there's in fact nobody that presently needs it, right?
Okay, agreed. So that essentially means whenever we want to kick something off, we could use it as a starting point and then basically enhance it. Fair enough. Yeah, thank you.
But
Right, so
from the working group perspective, that could mean this working group document expired before next meeting, then it's dead. Is that what you want?
But Sheng, I think if the Siemens folks want to reinvestigate what they want to get out of it, and then basically we work to make sure that it does solve that remaining use case, then we can continue. But otherwise, if we don't have a customer representation here, then maybe we declare it dead. Yes.
Yeah, I think it's okay if it dies. We don't have to publish every document that we thought was a good idea at one point. They could become silly. The problem space still exists. How do I resell a device securely? And how do I build an assembly of devices which results in a new device which I sell? This document actually didn't solve that second problem very well. And it may be that the way it solved the first problem was broken. So I would say that we need to have more interaction with end customers to be more precise about what they need, right? And I'll also say that some of the desires here came out of the reviews of Brewski about being unable to do these things, and I don't know. Some of that's water under the bridge at this point, right?
Okay. Get it. You can continue, Terence.
Right. Thanks. Next slide. Okay, so this is unchanged text, right? So please make sure that when you're getting with your documents closer for an intended working group last call, that you did have enough reviews on the document. And one way to achieve that is to offer, in return reviews for other authors' documents, so that we don't have to struggle with the working group last call and documents that haven't seen enough good reviews on them. And we also, of course, always have the early reviews. So especially try to figure out which of the other directorates, IoT directorate, for example, security directorate, the Yang doctors and so on, may need to review the document anyhow, because it does affect security, IoT cases, and has young models in it, just as an example. And make sure that if that hasn't been done, that you'll contact us chairs, and we'll help to put those early requests into the queue for the documents. Next slide. Okay, shepherding, always a good thing. We mention that every time, and if your document still is missing a shepherd, please, look around for the other authors who you think, not being a co-author on your document, might be a good catch, and contact us chairs. Next slide. Okay. So these meetings often are rushed because we have a lot of items to work on, and then a good amount of processes to deal with that. If you feel that your document would need more time for a discussion, then please bring it up on the mailing list, talk with the chairs. It's always not difficult to set up interims when enough people are interested to spend more time on individual subjects. Next slide. We obviously already have a weekly ongoing really good discussion team for most of the Brewski documents, and we'd invite you to also join that meeting to discuss your Brewski work when you're not doing that already. Next slide. And yeah, we don't have an official IETF GitHub, but pretty much all of the ANIMA documents and the individual contribution documents proposed for ANIMA are in the ANIMA WG GitHub. And when you want to contribute new work, we also suggest you to just get invited to that GitHub and put your documents into that as well. All right, and I think that is the end of the chair slides. And please go to the note page where we have the agenda. So that would bring us to slot number 2, which is an update on the constrained Brewski join proxy. And that should be Michael then presenting. And let me see. I think that's what I was trying to tell you. Yeah, wait a second. So I was here, constraint Brewski. Just give me a second. No, I'm still. What happened happens here?
Go to meeting materials.
Yeah.
No, you're going to share your screen instead.
No, I'm not going to do that. Sorry.
Yeah. So then you have them loaded. You just need to pick the right slides.
No, that just brings it up on my local screen. Sorry, I'm.
Yeah. No, it shouldn't. It should. You have the slides. No. Oh no, you need to click on that.
Right.
No, choose a deck to share. There you go.
Sorry about that.
Thank you. Oh, this is Esco's talk. Where's Esco?
There you go.
You're going first.
Yeah. You want this one first? Yeah. I think that's the order in which the requests were received. I think.
Okay. Well, it says he's presenting.
Yeah. What? Oh, I've listed here you with the constraint voucher. So did I just swap the presenters?
Yeah, we don't know. It's not joint first. No, it's voucher.
Okay.
I couldn't see an agenda, so I don't know.
Okay, crazy. Okay.
So this is the first working group I joined, which does not have an agenda in the IETF meeting tool.
What? Do I?
If you click on meeting materials and then agenda.
Yeah, we do. We do have the agenda, but
we do have.
put that
Okay.
in the note. Yeah, you have to copy that, paste that to the web browser. Then you can see that in the meeting notes or agenda.
Yeah, it's a link basically, yeah, to the agenda. Okay.
Yes.
I didn't get that
Yeah,
far
that
yet.
link works. Yeah.
Okay. Shall I get started then?
If I'm actually knowing how to progress the slides here. What happens here?
Yeah, meanwhile, you can look at the small Bruce keys on the top left side.
Yep.
So
Sorry
little beer bottles. Okay. I'll present the status of constraint Bruce key, also known as constraint voucher. So this repeats a figure from a while ago, already 2018. There was a request for working group adoption of constraint voucher and some very nice graphics to go with it. So this says need to fix names here. So that I think we have some new naming by now, but for the rest, it's still, still valid. Okay, so we have a long history, but it's still progressing all the time, not very quickly. So next slide, please. So we just tell you what happened since the last times we presented. To recap the goal, basically we would like to have a Bruce key bootstrap solution and one that works for constrained devices and constrained networks. I can take this off, I think. Yeah. So it's suitable for wireless 6LoWPAN mesh networks, but also for other types of constrained networks. So key differences are that it uses, for example, CoAP and DT-less instead of HTTPS, has COSE signed CBOR instead of CMS signed JSON, uses constrained EST CoAP-S. This is already another RFC. And in general, we want the overhead of messages and options to be minimized. So that's good for constrained implementations. So they need less code and the networks need to transport less data if we do that. Okay, next slide. So now we'll go by the previous versions that we made. This one is still from February. It might have already been discussed in a previous IETF meeting. Just as a recap, so what we did is we clarified their values for the assertion field. Basically it derives from Yang enum, but it's good to make that explicit for those people who are not completely up to speed with Yang. We did some editorial updates. And also we did an update of the Bruce key well-known URI subregistry. So we proposed to add a new column there, which is then to be applied by IANA in the end. Okay, next slide. We had a version 17 with some small changes, so particularly saying how we amend the Brewski RFC. And also a new section was added in security considerations. Okay, next. And then version 18 appeared. So we have there the number assigned to the content format. So it's application/voucher COSE plus CBOR. And also some discovery extensions were added. So there was a lot of the recent discussion was on discovery. And yeah, GRASP is now mentioned, co-op discovery. And as I understood, we discussed DNS SD discovery as well. And the idea was to keep that for future work. I think there's also some presentations by Torles on DNS SD coming up. And further editorial updates were made. Okay, next. So also implementations have been made over the past years, and we did interop between them. And this slide just lists the implementations, some with a little bit of detail and some links. You can go to the materials and click on them to see where that code is located. So it's 4 implementations listed here. Let me just summarize that. Yeah, most of the implementations include different components. So it's typically a registrar, a MASA, and the simulated pledge that needs to bootstrap. And then specifically on my own implementation there, it's the second bullet. I also, would like to mention that it's also meant to be a framework to be integrated into automatic testing, which means that it can not only produce the correct formats for vouchers, certificates, etc., but also produce some incorrect formats on purpose just to test compliance of devices to that. So to check that devices being tested will actually stop the bootstrap process or throw the appropriate error message. Okay, let's go to the next slide. So this says demo. I'm not sure if we actually have time for a demo. It's just very short. But I have to share my screen to do that. And as we know, it can take a minute. Let's see if that works then. Then we'll just. Oh, okay, it's first. Okay. Then I'll just ask to share screen. It's now unshared. So the request has been made. Now I think the shares could have to press accept for that.
I don't see anything like that, so hopefully you'll just get it.
Yep. And you have to answer some questions, whether I changed my mind or not. And then again, share, and then it says, are you sure? It's like a multi-click process. Oh, wait, I can't even press share. Okay. Mm-hmm. Okay, I can only share a window, it seems. No, that was blocked, the whole screen. So I'm just sharing this window. You see some Java code here. Let's see, is it readable at all? Yeah, this is just to show there's a list of tests on the left with a lot of green bars. So that's just nice to highlight that this repository includes testing as well. So you can run unit tests that will instantiate different topologies like a registrar, a MASA, and the number of clients, and it's all tested on local host. So the code here that you see will test multiple pledges. So it basically has a loop to create pledges. Maybe I'll see if the mouse works, then I can just hover over it. Okay, yeah. I can see the cursor. So it creates a number of pledges and then starts them almost all together. And then it waits for each pledge to finish. Each pledge will internally have code to perform a bootstrap process. So that's also a way to test the concurrency of the server in a very simple way. And there are a couple of tests like this. So every time we hit some interop issue, like wait, you did not use that flag in the certificate or in the voucher, then well, we can add a test here that tests a specific situation, and then yeah, to see that the registrar or the MASE handles the case correctly.
Is this now using all your implementation, or is this actually including testing of some of the other implementation code that you listed as interim rule?
Yeah, this is using only, let's say, my code, which is actually forked from the OpenThread project, I should say. So that's where it started. That's an open source project, but I basically made my own fork to develop further. So it does not test any of the others' codes, but you could basically use the software components to yeah, access other people's code. So maybe I'll just quickly try to share another tab. How would that work? Stop screen share.
And so the network setup in these cases without the proxy is that the registrar IP address is explicitly configured or on layer 2, or the or that you do have an untrusted network where you can do the discovery.
Yeah, so for this test, for example, it's all pre-configured, so no discovery at all. So that's quite simple, and it's also on local host. So all the discovery aspects are not in this code, actually. Let's see, window. No, I'll show something else here. You see a command line interface. I'll make it a little bit bigger. Yeah. Okay, so simple command line interface. You can start a pledge. On the command line, you provide yeah, an IP address basically of the registrar to connect to. No discovery here, just hard coded. And you press RV, and you get a lot of debug stuff. So at the end, it will get, yeah, basically some bytes here, and then it means that the voucher request was successful. So this went all the way to my cloud server in Frankfurt, just to make it more exciting because it's just a bunch of text. Okay, then you can do enroll, which is the EST enrollment part. So then it will print here the certificate here and the private key. Basically, that was the result of this enrollment process. So basically, the pledge creates the private key and then yeah, performs EST to get a signed certificate. Okay, then I'll just move back. Okay, stop the screen share. I think there was some content still on the slides. Okay. So we'll see what else it has. The next steps. Yeah, open issues and next steps. So we do keep the GitHub issue tracker. So that's the main, let's say, indicator of open issues that we use. At the time of writing, there were about 12 or 13 issues open. So we have also interop issues and future labeled issues. These are not really counted for the document. And yeah, there's just, I think, 3 important ones. The first one is to check all the examples. These are now outdated, so we have to check examples against the running code to make proper real examples also in the document. And I think the discovery section still needs a bit of update to match the new constraint join proxy that Michael will talk about. And there was one discussion item that I opened. So it's a possibility to optimize for constraint networks to reduce the data size by yeah, excluding one root CA cert in the handshake of the pledge. So that was an also GitHub issue opened for that, but that's open for discussion. So it's a proposal on basically how data can be reduced, with the assumption that the registrar has root CA certs already preloaded of all the devices that it wants to onboard in its network. Okay, and that's it, I think, yeah.
So I see from a year or more ago 3 early reviews, IoT, Dear and Genhard, and they said it wasn't ready. So do you feel that all their concerns have been resolved?
Yeah, I think at the time we opened a couple of issues on that on GitHub. I think these are now closed, or as far as I can see. So I did not actually check those feedback emails, but I think Michael opened at the time a lot of issues for those, and one by one we have resolved them. So I think I would need to check then it would be good to check the original emails, I think, to see if that's really the case.
Okay.
But I would assume yes.
Okay. Good. Thank you very much.
Okay, thank you.
Any more questions? Who has read the latest version of this draft? Two. Okay, not very many. Yeah, so try to find more reviewers. That's the usual thing, right? I mean, that's something when we get to working group last call, it's going to be probably the most important remaining aspect.
Right,
always.
yeah, and fix the examples.
Right. I think then let's try this Mr. Richardson again, shall we? And that would be then the constraint join proxy.
I decided to address for the dance working group, which is next. So there you go.
Next
Yeah.
slide.
Oh yeah. All right. Yeah, sure. You can go next slide. This document went through to through working group last call. I would say even I think it was even before the previous IETF, and then went out to the IANA for expert review, specifically on the topic of the COAP pieces, and the expert reviewers were a little bit displeased with our use of COAP discovery. And I guess in September, I think, maybe it was middle of October, a few weeks ago, we had a core working group discussion about that, and it overflowed into the IoT Ops working group, because they were in fact they were scheduled one on top of each other in virtual interims. And since we were all going to the other one, we just did that there. And the overall thing was, the question became, well, why is the join proxy format, where we went from previously we went from a bespoke CBOR to a encrypted bit of CBOR. And then the question was, well, why exactly is it not just a COAP header? And I said, well, because I thought that we were going to blow too many bytes doing that. And the response was, well, you don't need this, and you don't need this, and you don't need this. And actually, one of the questions is why RFC 9031, which was 6-tish minimal security, which does use a COAP header, why it has so many of those things. And the answer is maybe it didn't need them. The short of it is that we changed it. So this slide really just talks to you about what it looks like in GRASP, and there are several different ports that are returned. Next slide, please. And again, illustrating in GRASP that you need to you would do a discovery by the join proxy to find the registrar. And now what we return actually is not this weird RPY thing, but in fact just COAP. So next slide, please. So as I said, so previously we had this thing on the upper left, this built-out structure. Then we said, well, let's encrypt that in 114. And now we said, let's just make it a COAP header. Now, actually, this is wrong. The document is wrong. We're arguing specifically the proxy scheme option, which says COAP. We believe that we don't even need. So that actually saves another 6 bytes. The end result is that the cost of making it a COAP header versus making it this crafted CDDL in the upper right, it's actually only 2 bytes. 2 bytes extra to make it a COAP header and make it all look sane. So what I'd like, the working group, I've published this document, the new document with this code in it. I haven't merged the pull requests, and there's 3 of them piled on top of each other, because I don't feel like the working group actually has really had a chance to really say yes or no. So I'd like you to do that. Next slide, please. Yeah, so that's basically it, what we've done. It's a large change to the document at a very late state. And I would say the implementers are like, whatever. We had 6 changes, what's one more, right? But this at least makes the core working group and the expert reviewers happy. As I said, it cost us 2 bytes, and now it looks kind of really just correct. And the other interesting thing is that it aligns it pretty much perfectly with RFC 9031, which has OS core security and no TTLS. And Rob, thank you.
So this is just sort of like a process question, really. So I'm trying to understand. So Robertson, SIGs and AD. At the moment, it's sitting on my pad of things with an AD. I can't remember what the status is, AD follow-up or something. Does this need another working group last call? Should I formally return this document back to the working group to last call again? Do you think that's? I don't quite like the scope of the changes you sort of described. Makes me think another last call is probably.
Yeah, that's what I would like. I think it needs to go through a working group. Consensus call of some kind. You can call it a working group last call. This might be the 3rd one, or is that the other document we returned? But we have to come back to the working group with this. So that if you go look on the data tracker, you will see the diffs because I posted a new version. Okay, but if you go look in the GitHub, you'll see there's 3 stacked pull requests that make all these changes. Okay. So if you want to come back and see exactly what the changes are, they're there in the GitHub. And we can wordsmith them or whatever someone wants to do that way. But I didn't feel that it was right to merge it until the working group had a comment. But on the other hand, you can just go look at the document and you'll see the diff. Makes it very clear what's going on for that. So
can I jump in on behalf of the old community that still likes to have draft versions and RFC diff and everything? Just merge the bloody thing, put out a new version.
I did that. So yeah. I put out the new version from the branch.
Okay.
So you get both. You get the RFC diff and you get the GitHub. So you have them both. You can look at either way to see how it works. Okay. And that's why I did it that way. Yeah.
Okay. But so from the process, I'll return it back to the working group. Looking at the chairs, you're happy for me to do that? Yeah. Okay. Thank you.
And I would appreciate, chairs, if you did this quickly, and I would like to get this off of our plate, before people disappear into Christmas eggnog or whatever.
All right. So is there any good marketing for this other than we kind of got derailed into this because we started using COAP Discovery and then we got all these COAP experts and they wanted us to do COAP headers and now it's just 2 bytes, but is there any other benefit?
We are reusing, so if we assume that the join proxy is in fact an IoT device that otherwise speaks COAP, that we've just removed a bunch of bespoke custom code, and we're now using the common COAP code. So that might actually represent a code savings, but particularly the join code the join proxy code is code that probably doesn't run that often, and therefore probably doesn't get very many eyes looking at it. Whereas the COAP code that you would use is hopefully code that if you break your device. So presumably that means that this code is going to be much more better maintained, is what I'm trying to say, right? So the other thing I'll say is that, so Panos is one of the co-authors and he's still around. He's still doing CFRG stuff. He doesn't have a lot of cycles for this, but Peter has really declared himself as really retired.
So I'm the only author standing. So please, your comments would be welcome. Yeah. Let's go.
Yeah, Skordijk. Yeah, I agree with what you said about co-op. So you kind of reuse a code base that is presumably already going to be on the device. Yeah? That's the idea, the constraint device. Yeah, one thing is that it does have some impact on the behavior of especially the forwarding. So with the old protocol, basically the message was sent towards the registrar on a specific port, and then nothing happened. But with co-op, you basically, if you send something, it's in the form of a request, and a request gets a response normally. So there's suddenly in this extra message a response that we have to
I think we said it's non-confirmable.
Yeah, that's right. But you still get a response, so it's not an acknowledgement, but every request also gets a response. So even the non-confirmable ones. But the good news is you can suppress it. So you basically the server side could decide to just like generate the response and throw it away immediately, like, hey, it was lost. That's kind of allowed in non-confirmable co-op. So that's something we could do, but it is something to address, I think, to look at, that we don't want that 2.04 response message coming back, because it has no value in our case, I think.
So I thought we got it right in RFC 9031 that there isn't a response. You're telling me different. So I'll go back and review the two things, and I may ask you to confirm my understanding at that point.
Yeah, so yeah, the thing is with co-op, if you have confirmable, then you will get an acknowledgement to the message. And usually the acknowledgement and the response are combined in one, so it's the most efficient way. But if you do not have the acknowledgement, you can still get the response. So that's
right.
But the good news is that the server can basically suppress or throw away the response, and the client won't bother because it's not waiting for the response anymore.
I see Marco back there, who might be an expert. He's looking.
Yeah.
He's looking like no. So 9031 said confirmable, and I just copy and pasted that, but that sounds wrong now. If it's confirmable,
well, probably should be non-confirmable. The idea is that if something gets lost in the DTLS, for example, there will be already a retransmission happening by the client in the DTLS stack or by the server.
Yeah, so that's right. The pledge is going to retransmit himself. So there's no point in the proxy retransmitting. That would be silly.
Yeah, so it's non-confirmable. That's fine. I think that's a good way to do it. But you still get this, normally this thing with co-op, that it also generates a response if you have a request. So
right.
Could be suppressed as well, but it's an explicit thing you have to specify, I think.
Okay.
So
I hope the note taker has that, but I'll get it.
Yeah, I'll also try to remember that.
And Marco, we think that the proxy scheme is unnecessary. Did you see that message? You agree? Yeah. And Rob?
Marco, I haven't seen that message specifically, just backing ESCO. Yeah, if you send a confirmable request, you expect not necessarily a response.
Yep.
So it's not a way to say, I want a response back from you. That can come or not, depends on the application.
Okay.
So Rob Wilton, just going to echo one of the comments that Turles made earlier, that this working group's got smaller numbers of people, and I think there's a couple of documents here that haven't had that many reviews in this one. So and you're now the only author, so it's just a working group. If they want to get these documents to sort of make progress, it needs more sort of cross review from other people. So I'd really encourage people who are working any of the stuff in this working group to try and cross review each other's work, because otherwise when it gets to the ISG and those other reviews, it gets slowed down because you get a lot more comments. The more you get done in the working groups, the easier the path is later on.
Yep, absolutely. Okay, I'm done.
Okay. All right, then I think we're up to an autonomic mechanism for resource-based network services auto deployment. The authors have done an update since IETF 114, and I think Sheng will want to give the presentation.
Curtis, you need to stop your sharing. I can. Can you see my screen?
Yes.
Is that full screen now? Okay, this is the update for the working group draft network service autonomic deployment. Actually, we already changed the title a little bit. We add a couple of new words. One is the generic to emphasize the generalization of this mechanism beyond the quality transition service. And we add another word, management, to emphasize the dynamical autonomic management besides the autonomic deployment at the beginning of the services. This time, we actually already largely rewrite the description text without changing the document structure and the purpose of this document. We update the out deployment and management process of the quality network transmission services. We also check the resource manager object and update the contents. We add the 2 new subfields under it, and also their registry tables with initial value for ANA consideration, also some editorial changes. All those red words are newly added. This draft introduces enhanced and extensible mechanism that supports dynamically dispatching of network resources. As we said, we emphasize the generalization of this mechanism. In previous versions, the draft mainly consider a transition service, but the mechanism is oriented to more general services deployment and dynamic management. This mechanism is generic for most resource-based network service. It can be easily extended to support many network services scenario, including but not limited difference transmission service, in-network cache or storage services, computing services, information services. However, those services are only listed in this document. The detailed supports for those services are out of scope for this single document. As we said, it can easily be extended in future work, but probably another documents. We update the out deployment process. We change the one step discover the ASA into a two-step discovery process. It can discover the relevant nodes first, then discover the resource manager ASA on those nodes. Of course, it can come back as one step when they are actually deployment in the autonomic networks. It's the deployment choice. We also add new step for check the authentication of the service initiator and the authorization for the operation on resources. In principle, any operations on resource must be authorized the service responder should check the authentication of the service initiator and the authorization information. However, this document assumes all autonomic nodes within the autonomic network domain have been authenticated and their request operation are authorized, given the precondition the ACP and Brisky has provided this secure environment. We also add a new step to emphasize the releasing of resources. It must be done during the service ending. The service ending could be lifetime out or the service initiator notification. To generalize the purpose, also the resource manager, so we actually update the grasp objective. We use new parameters to identify a service, service type and service ID. We also added the service lifetime. The description, the expression has been reviewed by Brian Carpenter. The format has been modified based on Brian's comments, and we'll update in the next version, which we haven't done yet. We are planning to do another update after this meeting. Now with all these comments we receive this meeting and in 2 weeks' time, I guess. We also update the process of the quality network transmission service autonomic deployment. The service initiator discover a service path because normally this transmission service is from a source to a destination, which pass many network nodes, but they are all in a path. So the path should be discovered first, then the service initiator know all those nodes. The resource manager ESA on the service initiator negotiates the resources with the resource manager ASAs on the service responders one by one. But normally a specific network service should have only one service initiator within a autonomic network domain. I mean, for a specific network service. It's the service initiator's responsibility to manage the service and coordinate along multiple service responders to ensure the consistent of reserved resources. After the negotiation, the resource manager ESA on service responders also on the service initiator reserve the local resources. Those resources can be dynamically changed. We have that description in the document. Here we also give a example of negotiation process. Those numbers are arbitrary. As we said, we add 2 new subfield service type with 2 initial value. We think 4 bits is enough for those different service type because that can give us 16. The resource type, for now, we have the bandwidth, queue, memory, priority, cache, computing. For now, we think 4 bits, given the 16 value space, is big enough. But if experts think we need more space, reserved space, like 8 bits, we are happy to change that. Yeah, last slides. The next step, we are welcome to the comments, contributions, reviews. As Warren said, Robert said, we always look for reviews. So all kinds of reviews are welcome. We will continue to refine the contents. We also have an implementation plan using Python. Hopefully, we could done that by the end of this year. So that's 1.5 months time. We are targeting for working group last call after next IETF 116. By the way, Michael Richardson, your successfully confused me because this meeting is 115 and next is 116, right? Okay, that's all from me.
Thank you. Any comments or questions? Let's see if there's anyone. Yeah. Please go ahead.
Esko Dijk here. I had one question. Yeah, just wondering about the overall security model. Since the draft mentions that all initiators, for example, have to be authenticated. It also says that they are authenticated at the moment that they join this, yeah, basically ACP, I think it's called, right? Or the autonomous network management plane, basically. Is there an, yeah, maybe I missed that part of the working group. Yeah, is there some common assumption that, okay, once a device gets kind of onboarded onto the management plane, you can just, yeah, stay authenticated for the rest of the lifetime, or do we need some additional protection and to verify that this message was actually coming from who it was coming and that it was genuinely coming from that device? So that's more like a general question on the security model, I think. But,
yeah, we have the ACP experts and Brisky experts on site. There it is, Michael.
Yeah, I think that if we rely on the ACP, then all the communications that you're doing through the ACP will have effectively, you know, your authentication on the binding of the IP address to the certificate. And if you would be using, you know, just Brewski without the ACP and you have the connectivity and you're doing this type of service enrollment, then I think it would have to be through the Brewski certificate in your end-to-end TLS connection as the authentication. That part, I guess, this document doesn't say, because I don't think in general we've tried to figure out how to, you know, suggest more lightweight service provisioning without the ACP, but I think that would be the obvious way. Just, do you have the connectivity is then the question. But with the ACP, it is all derived from the Brewski certificates, but then you also have the secured, reliable connectivity.
Okay, so that's really tied to the certificate and TLS is what you're saying.
In the most simple case, you just you know, authenticate the certificate mutually through TLS or Quick or whatever you want.
Yeah. Okay, that's kind of independent.
This is basically written against the reference model. In the reference model, you have the ACP.
Yeah. Okay. Yeah, that's clear. Thank you.
Yes, thank you. Your question are really valid, but actually it's out of the scope. We just noticed in this document say it must, actually I used the word must be authenticated and authorized. But how to do that is out of scope. Okay, if there's no more question, I'm done. Dennis, back to you.
Sorry, just taking notes for what we just talked about. Okay, and then the next one would be the update on the JWS voucher from Thomas.
Yeah, that's correct.
Yeah.
So ask to share the slides. Where do we have it? Send vouchers. Share. So hope you can see the slides. So good afternoon. This is a quick update to the JWS signed vouchers draft, which is also running for several months already. And so this update does not contain any new content. It's just about restructuring, rewriting to make it ready for working group last call. So what is it about? So we are specifying here another voucher format, so in form of JWS JSON generic serialization, so based on RFC 7515. And so there are no young changes. And as said, from previous version 04 to 05 now, we have updated examples in the appendix. We have a big restructuring in section 3. So also the prototype objects and figures are updated, and some editorial improvements to the whole document. What else? Of course, we have a POC implementation for that, also together with Brusky PRM, which Steffen will report later. We have implemented this voucher approach and format, and we would be happy for inter-op testing with other parties for sure. Unfortunately, still Shepherd is missing, so would be also good if somebody would volunteer. And last point is so the authors agreed so that this document is now ready for working group last call, and we would bring it in the next step here. And that's it, I think. The last slide. No, that's all from my side. Any questions?
Thank you. Any questions in the room or in the? Let's see anything. This JWS, right? So I mean, this is something where would you find some good additional reviewers from the application area that is dealing with these JWS things normally? There's anything like a review from app area or so specifically for that JWS context? I'm just thinking about the experience we made with the co-op folks that during IANA review that tell us how to use their headers better on the proxy. So are there where do these JWS people hang out insofar as getting a review from them? Working group or so.
So maybe one option would be to ask the authors of the JWS RFC. And so what is it?
Which working group did JWS?
Looking it up, it's
not from IETF?
Standard tracks.
Oh. No, I meant
tracker.
The JWS format is not from us, right? Right. So who did the JWS format?
Jose working group.
Yeah, Jose, right.
So would it make sense to send a request for review to the Jose working group here?
Yeah, I think it's a good idea.
Sure. If you can do that yourself, that would be best. Otherwise, let me know, and I'll be happy to support that and ask the working group chairs there as well.
Yeah, I reach out to them. Thanks.
Thank you. Okay, so then we have the update of Brewski with the pledge and responder mode, Brewski PRM. And that would be Stefan.
Thomas, I just requested the slides.
Yeah.
Okay, so I would like to give an update about Brewski with pledge and responder mode, as Thomas already said. So we are in version 05 now, and there is a repository available on the ANIMA working group GitHub, and we track the issues there, and there are also the latest the latest source of the document is there. What we have referenced here, that's also a reference that we provide in Brewski PRM, is a general architecture or an abstract protocol overview about the architecture. So just to recap what Brewski PRM is doing differently compared to Brewski, Brewski PRM essentially reverses the direction for client and server between the pledge and the registrar agent, the registrar, and is doing that by introducing a new functionality which we called registrar agent. The registrar agent itself may be a standalone component or a separate component, or it may be part of the functionality of the domain registrar. So what you can see here are the different messages that we defined as part of the Brewski PRM draft. So it's essentially triggering the pledge to perform certain actions, like creating a voucher request or creating an enrollment request. And then the registrar gets back to the registrar agent gets back to the registrar and does the interaction with the backend infrastructure in the name of the pledge. So here, nothing really has changed. We have some further tweaks down here, which I will come to at the next slide. So you see that there is some exchange between the registrar agent and the domain registrar and further into the backend infrastructure. And once this is done, all the different objects that have been collected by the registrar agent, so that means the voucher and also the enrollment response, essentially the certificate, and also the CA certificates are provided to the pledge, and the pledge can consume all those data objects and can then operate in the target domain. So just as an abstract protocol view, we don't have that picture directly in the draft because it's all somehow too complicated to put it directly into the draft, but we have it as a reference. So what has changed from last version to this version? We meanwhile had a couple of reviews. So in summary, we have 7 different reviewers, which are not all of them are stated yet in the draft. So that is one thing I still have on the table to put the names of the reviewers in there. The review led to several technical clarifications, to some enhancements. All of them are listed in the GitHub. So that means that we have issues for each of the different things, and we address, or for each of the different comments, and we address all of those comments. So specifically, we have included as mandatory now a signature on the voucher. So that means once the voucher has been issued by the MASA and comes back to the through the registrar and through the registrar agent down to the pledge, the registrar in between has to provide an additional signature on the voucher. So that additional signature provides proof of possession of the private key, where the pledge has seen the certificate. So that means the public key during the triggering of the registrar agent at the beginning, and that additional signature is some kind of explicit authorization to install the voucher on one hand, and on the other it terminates the provisional accept from the pledge side of the registrar certificate. So that has been discussed in the design team and also been included in the document now. So we also defined a new endpoint for pledge bootstrapping status inquiry. So we had already status messages in the same way as they were defined in Brewski. So that means we had a status message for that we provided from the pledge back to the registrar agent once the voucher has been supplied and also once the enrollment response, so the certificate has been replied. There was some request to provide an additional specific endpoint to inquire the status of the pledge in case that, for instance, a service technician is stepping by and may not know if the pledge has been bootstrapped already or if the pledge is in some kind of intermediate state of bootstrapping. So for this, the endpoint and also the messages and the error codes have been defined. Regarding error codes, we have some, thanks to ESCO, we had some more integration of error codes there to have a more fine-grained or to enable a more fine-grained handling of errors that may happen during the bootstrapping. We put in some clarification regarding the knowledge of the MASA that is necessary for verifying the LDAF ID that comes in the voucher request from the pledge. So the LDAF ID from the registrar agent and also the LDAF ID from the registrar. So we require, meanwhile, that they have to be under the same administrative control. So that means the MASA needs to possess a corresponding issuing or root certificate for that. To be able to verify the different data pieces in the voucher request, and based on that to issue a certain agent proximity. So then we enhanced the security considerations. So there were some questions regarding potential attack scenarios, and they have been clarified, and also the privacy considerations have been enhanced. So last point regarding the enhancements here is the registrar agent certificate. We had that in the pledge trigger as optional component included, and we decided to basically drop that because it's being provided in the registrar created voucher request, where the pledge voucher request is part of that registrar voucher request, and we saw that because it's optional from the pledge side, it complicates the handling. So we would like to have some simplification there, and to also save bandwidth between the pledge and the registrar agent. So those were merely the technical points that have been addressed. And then we had some further clarifications and editorial improvements, and they relate to a lot of terminology, like enrollment object, certification object. So we aligned that type of terminology. We also clarified that the combined pledge may act as server and client for further re-enrollment cases. So there may be cases where a pledge supports both ways, so push and pull for the enrollment into a new domain. We also clarified that the registrar needs to verify the response messages that come from the pledge and match them to the audit logs that he gets from the MASA also during the bootstrapping phase. So that is no deviation to Brewski. It's more or less emphasizing that this is a requirement on the registrar. We also clarified that the pledge shall use a created on time from the pledge voucher request trigger object that he gets from the registrar agent in the cases where there has been no time synchronization been done before. Then we also removed the reference to the CAP forum. It was not needed anymore, so we basically dropped that reference. Then regarding the general structure of the document, we completely restructured section 5 to make it better readable and to better have a red line throughout the document. So I hope that simplifies the reading of the document And in that context, we also reworked all the different prototypes that we had in the different sections there. For the prototypes itself, we now have an appendix that lists different examples for the objects that we have, and also includes size information. That was one of the issues or one of the points that has been raised, because one intention of BRUSCI PRM is also to allow for different transport means between the pledge and the registrar. So that means we don't necessarily rely on protocols like TLS or TCP, since we have the security handling on the object itself. And in certain scenarios, we can utilize the BRUSCI PRM approach based on Bluetooth, for instance, Bluetooth low energy. And for this, it is interesting to also list the message sizes in the appendix. Okay, so far for the update from the 04 version to 05, as said, the discussion on the different issues is available on the Anima side. So the only remaining open point that's not a remaining open point for BRUSCI PRM standalone, but for all the different documents that define vouchers, there is some definition or some clarification ongoing on the Young usage there that relates to augmentation of the Young documents that we have there to enable the combination of different drafts that we currently have that relate to the voucher handling. So that is an issue that Michael took over, and that basically needs to be applied to all of the different Anima documents defining vouchers. Then, as Thomas already said, we have, since we are utilizing the JWS voucher heavily within BRUSCI PRM, so the JWS format approach, we have a proof of concept for the implementation available. That's available for all of the different components. If there is interest to do inter-op testing, please get in touch. The addresses, the contacts are available on the first slide. As in the last working group meetings, the document shepherd is still needed for the document. And here we are in the same situation as for JWS voucher. From the ARSIS perspective, after the review of 7 different persons, we now have addressed all the different issues, except the first one. So besides that, the authors agreed that the document is ready for working group last call. So that would also end my information or my update about BRUSCI PRM. Any questions?
Yeah, thank you very much. Let me see if there are any other questions. So if the open issue is clear in the document somehow, then I think before we go to working group last call, maybe we want to consider early review from, I guess there is a Yang usage, right? So the Yang doctors, and do we think that the security aspects are relevant to ask for early security review? I mean, I think the best feedback we've gotten in the early reviews was always IoT DIR, security, and Yang, right? In your opinions? Because then I think I could simply trigger those first.
Yeah, I think it would be good to have the security review as early review. I think that's probably fine. The persons that did the review so far were all experienced regarding security, but I think it's good to have already the first review from the security community there. Regarding the Young doctors, we had an early review, which from the Young doctors at the very early stage of the document. Since then, the voucher itself hasn't changed much, and I think we should do that once we have the clarification on the Young usage to avoid any problems with augmentation of the voucher.
Okay, so this is not ready yet. The Yang is the open issue.
The Yang is the open issue, right?
Okay. 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 I'll trigger the too early reviews. What's the plan to get these Yang issues resolved? It seems to be for the augmentation stuff. Who's leading that? Whom are you waiting for? I guess
Michael.
Michael.
Yep. I'm not quite sure if Michael is still in the room.
Yep, he's.
Ah, perfect. Nice pens, by the way.
Yeah, I'm dressed for the dance meeting. And there's other reasons. Yeah, so the augmentation, so if you go back to beginning, I just looked at my inbox, beginning of August to the mailing list. I posted the last efforts, and Jan Lindblad told me how I did it wrong, and I just need to repeat that. And I was just trying to figure out whether I can do that tomorrow afternoon, whether I'm awake enough. And so we'll get that. I'll get that cleared out. I said I'd get that cleared out for this meeting, and I think we can do that. The big concern is that we got something wrong in 8366, and we have to revise that. That's the big worry, is that we can't combine things. And if you go back to that document or that emails in that thread, if I can repost it, or I will repost it tomorrow, then you'll understand what I'm thinking about, right? So I know that Stefan, you have it. It's just really for the rest of the other people. We just need to do the simplest, stupidest experiment of combining things from different places and see that we can do it, and that we didn't make we didn't do the Yang wrong. And from the feedback I got is that we maybe need to do it slightly differently. So we'll see. Someone was behind me. Oh, okay. That guy just disappeared. All right. I thought he was getting at the mic. Thanks.
All right. Any other business on Brewski PRM? Going once, going twice, and slot number 7. Update on Brewski alternative enrollment, Brewski AE. That would be David.
Right. Can you hear me?
Yep.
Great. Could you share the slides, please?
I can try to do my very best. Brewski AE.
Great. Yeah, so today I'm going to give an update on Brewski AE, the changes between version 2 and 3. Next slide, please. As you will recall, Brewski AE is a variant of Brewski that uses an alternative enrollment protocol rather than EST. So what you see in the orange dot marked dashed box is any certificate enrollment protocol that has self-contained signed objects for the requests, which then supports end-to-end security for the certification requests. And there's good news on the document because now we have 2 more reviews, or actually 3. One was Seamless Internal, other one was by Michael, and another one was by our shepherd, Trolles. I'm very glad that we have these reviews in place now, and this gave valuable feedback, which I and the other co-authors implemented in the text. So we did several editorial changes and also clarified various requirements which were kind of implicit. So nothing surprising, but still good to state them clearly. And I can best show this at the picture itself. Namely, on the left-hand side, you can see the messages going from pledge to the registrar. And on this channel, we, of course, reuse the existing TLS channel. And what we didn't mention so far is that the enrollment protocol that is being used here, of course, needs to support this. So it must be a protocol that can be piggybacked or on an existing TLS channel. Another clarification was that the same protocol, of course, the enrollment protocol needs to be used between the pledge and the registrar, and then also onwards to the RA if it's elsewhere outside the local domain. So of course, we need to use the same protocol in order to have the end-to-end property that we are after. And another pretty obvious thing is, of course, that the registrar needs to support at least one such enrollment protocol with self-signed objects for the requests. And a fourth thing was, yeah, that the registrar itself may already do part of the domain of the registration authority functionality, or it may delegate part of this or all of this to an upstream RA component, which is somewhere else in the PKI. So the Brusky AE has better flexibility where registration authority functionality is provided. Yeah, I think now we can switch to the next slide. I already mentioned the various clarifications that we did in the document. And here I only wanted to mention that we did quite a number of small editorial improvements, for instance, on the comparison between plain Brusky and Brusky AE. Also a better differentiation of the various flavors of RAs, for example, local RAs in the registrar and PKI side RAs in the backend, and better description of offline message transfer versus synchronous message transfer and so on. So not really big technical issues, but just for better readability, some various improvements. And one further thing that happened in the meantime is I reached out to Elliot Lear about his contribution of EST full CMC. And it turned out that he simply doesn't have time to follow up on this, and apparently the interest also diminished somehow. So we agreed that he would drop off as a co-author, and now he's listed as a contributor. And we have left out the details of EST full CMC, which were anyway not finished at all. So the focus of the document is meanwhile the CMP instantiation. But of course, we do mention that there is the possibility to plug in other certificate enrollment protocols that also offer the self-signed, not the self-signed, the signed self-contained request objects for getting the end-to-end property. Yeah, and now I think we can go to the last slide. So to sum up, all open points that have been open recently have been resolved meanwhile. There is a POC implementation. We have the decision to remove the EST full CMC flavor instantiation of Brusky AE. We got a working group review by Michael, and we got the Shepherd review by Torles. And so we believe the document is now ready to working group last call.
Okay.
As far as that with my presentation, and do you have comments on this or questions? And how about the last call?
Yeah, I think the typical thing in terms of any earlier reviews that we would like to do, security, for example. Not sure if that should be done or in parallel before working group last call, but I think we could as well, unless there are opposing opinions, start working group last call with this one. I mean, at least from the Shepherd side, I'm fine with that, but
Thank you.
I'll discuss with Sheng on the share side.
Thanks.
Okay. Great. So where are we? I think we're at the end of the working group draft. I think Michael was saying that he would like to have some minutes on the hackathon, which I consider to be somewhat related to working groups, so I wanted to make sure that we spend the time first on that one.
So what I want to talk about was the Hackathon VPN, which Brewski implementers have tried to use over 2 years. Don't know if we ever got it ever working. I know Peter tried and I tried and it worked for a while. So I had a couple meetings with Charles Eckel, the Hackathon guy, and we then met with the IETF NOC. And they would love to do all sorts of things for us. But the short is we just like it to work. But essentially what's going to happen is that if you have or want to buy, like it's a €20 MikroTik router, the smallest one they have, will run the L2TP stuff. And then you wind up with a Wi-Fi and an Ethernet, which is essentially layer 2 bridged to the Hackathon network, at which point you can plug in whatever physical devices or thread gateways that you want. And they said that we probably can have DHCP v6 prefix delegation as well. So you can have prefix for your 802.15.4 network. The caveat is that it probably won't work for about 10 days before each IETF, as they take their equipment out of the rack and ship it to the IETF, and for about 10 days after the IETF. So it will actually probably work. I think they said it will work while the IETF's going on, which is maybe less interesting for remote people who are physically present, right? But between IETFs, we can have a network that we can do things, and we can do all of the MDNS, GRASP, etc. type discoveries, because it's a layer 2 network that we want to be able to test. So I think that's really all I wanted to say. I don't have a start date for it. I presume it'll just start working. Mine's up and running. What happens is that when their equipment is being shipped, you wind up with a VPN that appears to be up, but it's not connected to anything, right? And so I presume sometime in a week or so, in 10 days or so, it'll just start working again. As they say, they'll turn it back on. And they've considered other ways of doing this, including the possibility that during IETF week, we would be able to just essentially turn on anything anywhere, and we'd be able to get onto that network and it would work. I don't think that was as important, because I think we're almost all too busy to during the week to actually do any work. It's afterwards. So I just wanted to let the group know this. And I mean, I had a Raspberry Pi, is what the previous generation of it was. That was harder to use. And although I have some reservations about GPL compliance of MikroTik routers, I was happy to just pay 20 some units for a tiny little device that just seemed to work. So that was it.
Okay, thank you. So is Roland in the room? Yeah. So I'm happy to revert our slots, because I don't have high priority in reviving my drafts. I put them on the agenda, but let's go first with your Kira thing.
Yeah, I asked for the controller, so if you...
So present your slides. Give me a second.
Yeah, so I'm Roland Bless from KIT. And yeah, this is joint work with Martina, Zora, and Artur. So I'd like to introduce briefly Kira, which is a scalable ID-based routing architecture for control planes. So quite a nice fit for Anima here, I think. And its name is comes from Kademlia directed ID-based routing architecture. I don't have the control.
Nope. You have to say next slide.
Okay. So what Kira aims at is interconnecting a large pool of network resources, being compute, storage, network, what have you. It provides resilient connectivity for the control plane, so that the controllers, like SDN controllers that control SDN switches, can exert their control. And we also, since we are ID-based, we provide stable addresses for moving resources like virtual machines that move, or drones, what have you. Next slide. So what it provides is massive scalability. So we scale to hundred thousands of nodes. It is zero touch, requires no configuration. It is quite fast in convergence. It's loop-free even during convergence, which is also nice for robustness. It is works well in many different topologies. We call this topological versatility. So instead of having specialized variants for, let's say, denser data center topologies, we don't need that. So, and we also aim for efficient routes, but connectivity is first, so to say. So there's related work for sure, but they either like one or the other property. And for example, Ripple here, which would cause traffic concentration near the root. And it's probably not really zero touch since you always have to say what's the root node. I mean, so next slide, please. Yeah, so the main concept is that we have two tiers. One is the routing tier where the routing protocol lives, which we call R2CAT. And the other one is the forwarding tier. So the routing tier provides uses ID-based addresses, and it uses source routes and works on top of any link layer. While the forwarding tier can be seen as some kind of optimization. So we try to get rid of source routing due to the overhead. And the path ID-based forwarding is some kind of label switching approach that simply reduces overhead. Next slide, please. So I will talk briefly about R2CAT. Next slide. So the main idea is that we need some kind of path discovery. So in order to find path through our network, since we're in unknown environments. And so here we have a simple topology consisting of the white node, white bullets here, the white dots. So this is a link layer topology, and each node simply creates randomly a node ID, which can be seen as the uppercase letters in the blue dots here, in the blue circles. So moreover, every node learns its true vicinity. So for example, here X learns the contacts, which we call them, as they're also called in academia this way, A, Y, B, and M. Next slide, please. So now how can X learn a path to Z? So the approach is basically to construct underlay routes by using the node ID-based overlay. So the source route to the contact that is the closest to the destination node ID is simply used as next hop. And if we mention closeness, we need some kind of metric that tells us what is close to each other. And we are using the XOR metric from academia for that. So that boils down basically to if in case two nodes have a longer shared prefix, then they are closer to each other. Next slide, please. So in that case here, for example, if we assume simply for simplicity that letters here close on the alphabet also resemble closer node IDs, then the next overlay hop for X would be Y, since it's in the true vicinity. And we assume, so we know that we can reach Y via A. And so we assume that Y knows Z already, then Y will forward the packet via source route to Z. So in order to find a path, we usually send so-called find node requests out. And so here the find node request that eventually arrives at Z will record the complete route that the packet traveled. And this naturally incurs some path stretch, so that is not necessarily the shortest route. And also here it contains a cycle, but we can get rid of the cycle. So next slide, please. So the answer packet usually eliminates already that cycle. And later packets can even do better. So in the sense that X knows a shorter route to M, so it can take a shortcut. So that reduces stretch, and in case you have, or can afford to have state for later packets, then you can achieve lower stretch values. Moreover, R2CAT offers a flexible memory stretch trade-off due to its routing table design. The next slide, please. So the routing table is basically the same as in academia. So it's arranged by the XOR distance. So we have buckets of fixed sizes, usually of a small number, k equals 20 or 40. So that's the bucket size limit. And the bucket here, the topmost bucket here, the gray one, that contains the context G, for example, that holds all the contacts from half of the ID space, which could be quite large. And in that case, that the ID-wise overlay needs always to, or is based on the property that you know your ID-wise neighbors. There's a certain strategy that causes buckets to split once they're full, in case they're in your ID-wise vicinity. So lower buckets usually contain your ID-wise neighborhood. So next slide, please. So what we do now, in addition to that, is that we call the discovered path as path vectors for each contact. And we can do so in a way that we prefer always shorter routes. And that leads to efficiently learning the shortest path to the contacts. The size of the buckets is choosable, so on a per node basis. So in case your node can afford more memory, then you can have thousands of entries in your routing table, so that achieves that flexible memory stretch trade-off. And basically, we scale logarithmically with the number of nodes. Next slide, please. So with respect to dynamics, we assume that we have some kind of detection of node link failure in the underlay, and then we have it performing a two-step strategy. The first one is that we inform the ID-wise neighbors about the fatal link. Here, for example, X informs Y and Z about the fatal link. Next slide, please. And so the second step is to rediscover alternative path via the overlay strategy that I just explained, but this time including a not via information telling other nodes that may not heard of the broken link that they cannot use path that contain the broken link. And furthermore, periodically, since it's not guaranteed that the routing updates or that information about the broken link is spread over all nodes that need that information, you just check regularly whether the path to your contacts work. And you also have to look up your own node ID in order to keep the overlay together and to detect network partitioning, for example. And we ensure the validity of the routing information by using state sequence numbers and also path information ages. Next slide, please. Yeah, so briefly, what's it about the path ID-based forwarding? Next slide, please. So there are many backup slides, don't worry. So the forwarding tier now tries to get rid of the source route for the control plane packet. So in case we want to SSH to our router, Kira provides the connectivity, but we don't want to have source routing for SSH packets just to get to the router. So the approach here is to replace the source routes with so-called path IDs. And the path ID basically is just a hash of the node IDs of the source route. And so the path ID is used as label for the source route, and then basically we do some label switching between the nodes. And the reason why we need the true of physical vicinity, which isn't actually required for the routing protocol itself, but here for the path ID forwarding, it's nice because we can pre-calculate the path IDs in the true of vicinity, the physical vicinity, and so we only need path setup for paths that are longer than 4 hours. Next slide, please. So we implemented that thing and showed that it works on top of IPv6 packet formats. So we just provide IPv6 connectivity out of nowhere, so to say, with Kira. And then the data packets can use the faster forwarding, the forwarding tier, which requires a node ID-based forwarding table and a path ID-based forwarding table. And in order to use path IDs in addition to the node IDs, we simply use GAA encapsulation. So there's one additional header for that path ID-based forwarding in the current scheme. And so your control plane app, if it's able to talk IPv6, then it runs simply over Kira. Next slide, please. Yeah, we simulated that because I claimed that it's highly scalable with 100,000 of nodes and so on. So here are the details. We tested in various topologies. Next slide, please. So this slide shows its performance in various topologies of size of 10,000 nodes. And what you can see here is that, for example, the average multiplicative stretch along the y-axis, while the different topologies are along the x-axis. And the first packet stretch for the first packets that we need for path discovery are the green dots here. And you can see that it's even lower than the ACP variant of Ripple. So we are not doing so bad, even while we are doing overlay-based routing, more or less. And also the blue triangles here are showing that the stretch for the later packets can be even lower. And the really nice thing is that in all topologies, we learn the shortest path to all the contexts that we know. So you always have shortest path in your own routing table. But in order to get to other nodes that you don't know, you have to at least have some stretch, right? So next slide, please. Yeah, and dynamic-wise, we are also doing quite well. So in a 100,000 node topology, when 15% of the links fail randomly and simultaneously, which is quite a large outage, I would say, you see that it's able to get back to nearly 100% delivery ratio for the controlled packets, and also then for the data packets a little bit later, within 10 seconds, roughly. And the overhead is small, so we're not flooding, right? So due to the small size routing tables, we can do quite well with the overhead of the whole protocol. So we have here nearly 80 packets in average per node per second that is sent in that kind of failure. Next slide, please. Yeah, so that concludes already my talk. So there are more backup slides in case you're interested. There will be a side meeting today, so at 7 in mezzanine 12 here. There's a small room. So Kira is actually designed for large provider domains. It's could be a replacement here for Ripple in the ACP, but we're not standardized yet. So the idea is to start that off here. So I have to write internet drafts and design packet formats here and so on. Ripple was designed for IoT. So Kira was not designed for IoT in mind, but for fixed networks basically. But I guess we can tweak also to that. We simply use link local addresses, as I said, so that can be used out of the box in that sense. The nice thing is that it offers more. It offers integrated DHT for simple name resolution services and discovery, and that could lead to a more efficient and simplified discovery than with GRASP, what you do here with GRASP. It also supports multipath routing and forwarding due to the path IDs, for example. And it also supports scalable and efficient topology discovery. So within 5 seconds, you can basically discover 100,000 nodes topologies with nearly 100% of all the links in 5 seconds. So that's kind of amazing, yeah. That's it.
Thank you very much. Any questions? Michael?
Thank you for this presentation. So is it your goal, you're having a side meeting, or do you think you're going to form a working group, or what's going to happen with that?
Yeah, I mean, yeah, I want to just see whether there's interest, what people think about it, whether it's useful. I think for future networks, we need some kind of robust control plane connectivity.
Yeah.
Because you know that people misconfigured BGP at Meta and then they lock themselves out of their own control plane. That is impossible with Kira in that sense. In case you have physical connectivity, you will get there.
Right.
And so that's really a robust way for your control plane connectivity. So yeah, the idea is maybe, I don't know if I think I have to write IDs first, and then maybe next time we can have a BOF, official BOF. I don't know. But it's not it's not useful unless you have Kira in all your resources. So that's why we need to standardize it.
Okay,
right?
so it had two thoughts. One was that ACP, is intended to run over a secure overlay. We're using, point-to-point IPsec.
Yeah.
One of the pathologies when we have layer 2 connectivity that doesn't participate in the ACP excuse me. One of the pathologies is we form too many adjacencies, right? If you have a layer 2 switch that connects a bunch of layer 3 things, is that you wind up with this mesh, and it's silly, right? Because you just don't need everything. On the other hand, if you have actual real, devices separated by cities and stuff, then the connectivity really makes sense, and you have the right things. But despite that, what we don't have in Ripple at this time is any kind of reasonable origin authentication. So we have all the security. We know which node has which IP address. We even have certificates that attest to that. But our routing protocol actually makes no use of that fact to make sure that our control plane part of it hasn't gone bad. And it's not just, to my mind, a question of a defense against maliciousness, but it's a defense against, as you said, Facebook, or Rogers in Canada had a worse meltdown on July 8th. They didn't just lock themselves out of data centers. They just toasted their entire control plane to the point where they couldn't even phone each other up to say, go fix it, because their phones didn't work, right? But, it would be nice if that security was also providing for defense against misconfiguration. And so that's something I would really be excited about. The other part I wanted to end is, it sounds to me like we could run Ripple and Kira at the same time. Now, we don't have a big installed base of ACP, but imagine if we did, right? That finding those cross links and not going through, as you said, going through the NOC would be an interesting thing. Well, I mean, I don't know, there may be some synergies here that makes it worthwhile, or maybe a stupid thing to do, just wasting more time. But anyway, it's a thought that, that I had.
Yeah, just two thoughts from my side. One is, Cura has a nice property that it naturally thins out very dense topologies because of its small routing tables. And the other one is we didn't consider security right now, but you naturally can use node IDs out of a hash over your public key so that you have self-certifying identifiers. And since we are using path vectors, we can do any sort of having integrity protection for our routes, right?
Yeah, so it's not the integrity. We have that part. It's this route really did originate from that node, right? That's the thing. It's that, so like, right now we have, in BGP, right, we have RPKI, but what we're missing is route origin authentication, right?
Yeah.
And so that's the kind of thing that I'm saying. It would be interesting if you could consider that from day one, so that it's not a retrofit, because everything else is a retrofit.
I know. But we need to got this working first, and then I think we can put on many security mechanisms if we want to.
Yeah, I have one question too. What I was missing was a little bit better understanding the forwarding plane that you get ultimately, right? The path vector and stuff, that didn't sound like you're sending just a packet, and hop by hop you have the forwarding state, the routing table entries, but it seemed like you're still carrying some path information in some packet header, right?
So when you send a packet with path ID, you basically have a GRE header that has the path ID as destination address. And once your path has ended, then you can simply drop the GRE header and use the node ID for regular forwarding.
Okay, so you have on one segment, you have GRE is just one of your choice, is the choice that you came up with.
Yeah, but you can use segment routing headers, what have you. So there are many encapsulation possibilities to encapsulate the path or put the path ID.
The GRE key as the key is the path ID, or which part of GRE are you
so you just put the as destination IP address, the path ID, and then you have
the destination. Okay. Yeah. Right. So okay. And is there always only one such path element, or are you having multiple of them, for example?
Yeah, you can. So the path ID concept is basically capable of using multiple path IDs, so you can do multipath routing if you want to.
No, I'm saying that to get to a particular destination, how many steering points do you need across the network? You're sending a packet. You're basically saying the first address you're routing to is the end of that path, which is known on the path segment. Up to
Yeah,
that
okay,
point.
okay, I see. Yeah, so it depends on the topology. So the larger your topology is, the longer the higher the number of intermediate hops that you need, and that grows logarithmically with the size of the network, typically.
But this forwarding plane stuff would be good to highlight better in slides, because that's I think
Yeah, no,
ultimately what we're looking into.
just to
me,
yeah.
it's fairly clear that by using source routing and having an incremental set of source routes that help you to get closer to the destination is one of the cool ways on how we can achieve better than what Ripple does. But I think that's exactly the stuff that we want to review, and what also I think the forwarding planes that have this ability, like MPLS or SRv6, or obviously Ripple has it in its way too, although they're using it differently, right? But all these source routing headers might be exactly what you need to interact with.
Yeah, so we're currently trying to optimize a bit on the path ID forwarding, requiring fewer entries in the intermediate hops. But we didn't, so we have the concept, but we didn't program it into the simulation. So we want to have a better understanding how many forwarding entries are actually required in the worst case. And that is, I mean, we are very scalable in the control plane of Kira itself, so to say, but on the data plane for Kira, we need to figure that out. But it doesn't seem too bad. So it's, I think the worst case is square root of n, so which is manageable usually by modern switches or routers.
Well, I mean, we're not in the routing area, right? So ANIMA, so
yeah,
that
sure.
makes it kind of not well suited for this. But typically, in the
recent
past,
user.
in the past few years, everybody who had a really good routing idea got his own working group, right? So if you work hard to.
Yeah, I know. Then I have worked for at least 5 years more.
Right. All right.
Thank
Thank you very much. Okay, I think we've reached the end of time. Sheng, do you want to close it down?
Yeah, we finished our whole working group document update. We still don't have enough time for the non-working group documents, including two from Telis. Whatever, the first working place for IETF working group is the mailing list. Please do evoke the discussing mailing list. That's all from today. Thanks you all. Hopefully see you in Japan. Thank you.
Bye-bye.
I'm pretty sure it's just because